I think there's agreement that in the next couple months, especially by July, we'll know very accurately whether we're going to have a super El Nino or just a normal, so weaker El Nino. But it does it really matter because in 2023, 2024, we had a so-called normal or moderate El Nino, and that still drove global average temperatures above 1.5 degrees. We hit, in fact, 1.7 some months.
Hello, and welcome to another edition of the Climate Emergency Forum. I'm Herb Simmons, author of A Climate Vocabulary of the Future, and I will be your host today. And if you see me in the background in a little sort of rectangle, the reason is because I'm out of town. I'm actually in the wonderful windy city of Chicago for the conference of the Society of Environmental Journalists. Hundreds of environmental journalists from around the country and indeed around the world talking how we can better prepare ourselves as journalists, as people who translate climate and environmental issues to the public. And I'll have more to say about that in future programs as the conference is just beginning today. But thank you for being here with us. I think most of us who watch this are familiar with the fact that every couple years or so, there is what's called a La Nina or an El Nino, where basically there is an acceleration or a deceleration in heat and extreme weather that tends to originate in the Pacific Ocean. And it looks like we may be in store for a whopper of one this year. We don't know for sure, but we'll be discussing today what we might expect, what the implications of that, basically how this occurs, why it happens, and what we can do with it. And as always, we have our panelist, Paul Beckwith. Paul is a climate system scientist from Ottawa, Canada. And Paul, you have a very popular YouTube program on every aspect of the climate emergency. Unfortunately, our other panelist, Dr. Peter Carter, will not be with us today. And please, if you like this program, please like it. Subscribe to our channel. Go to our website, climateemergencyforum.org. And if you're so inclined to donate, we would greatly appreciate it. Leave us your comments, give us your ideas for future programs, and we thank you again for being a loyal viewer. So, Paul, we've got a El Nino coming up according to the scientific community. Nobody knows exactly sure when and how it will arise, but I know you've been following El Ninos for many years. So give us your perspective, Paul, on what's in store and why.
Thanks, Herb. And thanks always to Heidi and Charles, who are mostly behind the scenes, although I do encourage them to overcome their shyness and come on the program sometimes. I'm sitting back intentionally to advertise Ottawa, my dad's shirt. Anecdotally, there's an Ottawa in the US that just had a tornado strike in the last couple of days. I don't remember which state, but I'm not there. So if you're up in Canada anyway, come and see me for coffee. Interestingly, our timing for this video is perfect because James Hansen has a new blog on his site titled Super Duper El Nino, and it follows up from one a couple weeks ago called Is a Super El Nino in Store? So first of all, we don't exactly know for sure how big an El Nino will be. And the warm water tends to develop off the coast of South America traditionally, but we've seen in the last few decades a shifting. So some of the warmest water is actually more in the central to east Pacific. So the nature of the El Nino, the whole cycle in general is called ENSO, El Nino Southern Oscillation, because there's other effects associated with it. You know, we basically get a warming of the ocean, the sloshing of the water, and then the opposite, the La Ninas, or a cooling of the water. Our prediction isn't fantastic on these things. We're getting better, but the models tend to overemphasize what the sea surface temperatures are, especially something called the Nino 3.4 region. It's a central region of the Pacific. And the water temperature at the surface tends to be a big part of people's models. And what Hansen and others have found is that there's actually better correlation if you take the temperature of the top 300 meters of water in that region. His most recent blog is looking at that. First, I want to qualify that there's some groups that around the planet that are saying, well, we're not that accurate with El Nino forecasts. There's something called the spring prediction barrier. And the people that are arguing we don't know for sure, weird things can happen in the spring that can change the results. So I think there's agreement that in the next couple months, especially by July, we'll know very accurately whether we're going to have a super El Nino or just a normal, so weaker El Nino. But does it really matter? Because in 2023, 2024, we had a so-called normal or moderate El Nino, and that still drove global average temperatures above 1.5 degrees. We hit, in fact, 1.7 some months. But we passed the 1.5 threshold that Paris talks about and the Intergovernmental Panel on Climate Change, that threshold. We passed that for 3 years. The average over 3 years was higher than 1.5, and it was driven by a moderate El Nino. The super El Ninos, the ones that come to mind are the 1997-98 was the biggest and strongest. 2014 to 2016 was pretty strong. 82 to 83 is a very famous one. This one here is still a bit of a question mark, but from what Hansen was showing in his blog today, he looked at the water temperature in the middle of the Pacific near the equator down to 300 meters, which is about 1,000 feet. He found that the anomaly for March was 1 degree Celsius in that region, and just in early April, it's turned to 1.6. So this is signs that we're probably aiming towards the super, but again, we won't know for sure. There's uncertainty. There is chaos in the climate system, right? The interaction between the atmosphere and oceans and the dynamics. And there's different models, and these models can be rated as the good, the bad, and the ugly based on their previous success. One of the so-called best models that we know of is the European Center for Medium Range Weather Forecasting. And they've come out on a limb and said, yeah, probably super El Nino. And then they provide all the evidence that they're looking at to come to that conclusion. Some people say, well, we shouldn't be so certain about these things. Hansen's view is that this is really part of science. We're trying to advance the science and prediction, and it's good when scientists can say, based on what we know today, we're probably going to have one. And then if they're wrong, they still learn tremendous amounts of new science and new mechanisms of how the ocean and atmosphere interact and work. So I think it's very important. Predictions are great. I think they're necessary. I think it's important that people that predict things later they do a forensic analysis if they're wrong or right and say, this is what I thought and this is why we're wrong, and next time we'll have a better prediction. So it's all part of the evolving knowledge on this climate system, I guess.
Well, let me push back a little bit because from what I hear you saying that, or really, you're really talking about what Hansen is saying, that even if we're not totally certain, it's important to have these predictions, even if they turn out to be wrong for scientific purposes. But it strikes me that it could be very unhelpful and maybe even disastrous for the public and for governments. If, for example, there is the prediction that we're going to have this extreme increase in heat and presumably the weather that goes along with it, and governments prepare and people get panicky, and I decide, or you decide, or a million other people decide, I'm not going to take my trip here, or I'm going to do that, and then it turns out not to be true. It seems to me that could do as much damage as anything. So let me just get your response to that kind of perspective.
Before the age of social media and widespread dissemination of what anybody says, essentially, right, including recognized scientific institutes, people didn't really follow it that closely. But now, if you have a scientific institute saying this is what we think is going to happen, I think it's important that they kind of express the uncertainty when they give their prediction. So, most people are familiar. Who hasn't had a bet with a friend? I'll bet you $10 this horse is going to win, or I'll bet you something's going to happen, right? And we're often generally losing money on these sort of things because we think we know more than we do. And there's even systems like Polymarket where people are actually betting on events that are happening in the world. So this is part of today's society that if you say something and you have any credibility behind you, it's probably going to make a mainstream news story, and then it might float around on social media sites. And then if it's important enough and affects enough people, then it goes to the rest of the world. I mean, the exception to that is your orange leader. I mean, he sends out 200 messages of craziness on Truth Social, and then Reuters is carrying half of them the next day, for example. Like that's too much information. But yes, I think it's important to qualify the uncertainty and to say we don't know for sure. I mean, one of the things I really like to read about when Hansen talked about something called the Kelvin wave. And this is where you get a wave, almost like a wave. Imagine one solitary wave. It's called a soliton, moving across the ocean from west to east near the equatorial Pacific. Lord Kelvin was riding his horse apparently along a canal or the Thames, and there was a single wave moving along which he could keep up with on his horse, and thus he studied the phenomena, and the Kelvin wave idea came in. So it's kind of like a wave of heat, and we're actually seeing that happen. There's a lot of different avenues of evidence to try to show what's happening, but there is a paper on, they call it the spring prediction barrier. And often predictions that are made about this time of year have been wrong historically because something's been changed. And the predictions from July on what the ENSO is going to do are much more accurate. So I think that's a key caveat that I want to mention. I mean, it looks like from the 300-meter stuff, which a lot of the models don't incorporate. So the 300-meter temperatures, it looks from that like we're going to have an El Nino later this year going into next year. We're going to have a warming El Nino, and the question remains as to whether it will be so-called normal or weaker El Nino versus a super El Nino, the warmest type. And if it is the warmest type, I'm sure we're going to break new global temperature records. And what we're finding after these El Ninos is the temperatures don't recover as much as they used to. It would happen, and the temperature can still be elevated. The behavior, like I say, of El Ninos and ENSOs and so on can change as the water is warming. We have marine heat waves. There's all kinds of different factors.
Okay, and I think it's important to note and be happy to have you elaborate on this. And you've sort of implied this or said this already, but that El Ninos have been occurring presumably for thousands of years, independent of anthropogenic climate change. So that we're talking about an El Nino affecting planetary weather independent of climate change. And now, in the last 20 or 30 years, increasingly climate change is an accelerator, is a force multiplier, if you want to call it that,
Yes.
that essentially will make the effects of the El Nino more severe. And basically, what you're saying now, what Hansen, well, what everybody's saying is we don't know to what degree that will happen. We're pretty sure if it does happen, it's going to happen starting this summer and thereabouts going into next year or so. That, I think, is fair to say there's great certainty that there will be an El Nino because that's part of the cycle and we've seen it. And maybe what we should do now, unless there are other scientific dimensions that you want to articulate, Paul, then maybe we should talk about, let's take a worst case or something close to a worst case. What might we expect, not just in terms of, well, it might be X temperature we reach, but what might we expect in terms of the average viewer? And I know we can't predict, no one can predict what's going to happen in Ottawa, United States, wherever that was. I think it's actually not far from where I am now, by the way, or any place else. But I mean, give us a picture of what the world might be like 6 or 9 months from now with the kind of super duper El Nino.
What I would suggest to people is there's maps online. So when there's a strong El Nino, it actually describes different parts of the world and what one can expect if there's a very strong El Nino. And you can find such a map showing what actually happened. Say, the most powerful El Nino in half a century is the 1997-98 one. So if you look at what happened around the world, there's lots of data on how that El Nino affected different regions. Now, if you take the global warming temperature, the average temperature since then, we've gone up a significant amount, right? We're rising in the last few decades about zero point 0.4 degrees Celsius per decade. If you go back to 97, 98, that's almost 3 decades ago, not quite. I mean, we're actually much, much warmer. Our background levels. I said the nature of the El Nino seems to have changed. There's less warm water making its way to South America. There's more being stuck sort of not in the middle of the ocean, but in the just east of the central part of the ocean. So you can just base things on those sort of things to try to come up with, how it will affect anybody in a particular region. But I mean, we're getting more and more extreme weather events because of the behavior of the jet streams slowing down and become wavier, getting stuck in place. We're getting marine heat waves around the world, and those marine heat waves can be persistent. And of course, El Nino, La Nina is all about ocean heat. So if the ocean's preconditioned and extremely warm in certain regions as opposed to other regions, it's not a stretch of the imagination to say, well, this is going to affect the El Nino, right? It's not just warm water in the Central Pacific. There's warm water over here from the marine heat waves. So it's really kind of like just take an interest in it and just see what's happened to your region. But I mean, that's about all we can do. But if you do that in great detail, you use AI as an assistance if you want. Then you can maybe figure out what's going on in your region, I guess.
Let me sort of ask you to go into the climate weeds a little bit, so to speak. We did a program, as you know, our viewers know, on the Earth's energy imbalance that has gotten much more extreme. And we talked about it in the context of Hiroshima bombs equivalent of energy. And we talked about the heating of the Earth through climate change and combustion is, a certain number of those Hiroshima bombs, that cloud cover that's disappearing, that's the marine fuels that are no longer being used with sulfur in them, et cetera. So I guess my question to you, Paul, and I don't know if you or any scientists know the answer to this, is to what degree are all these forces that are getting greater and making our energy imbalance more severe, more imbalanced, how does that affect the likelihood of an El Nino being severe?
How is El Nino changing with climate and with warming oceans and stuff? I mean, there's a number of, we don't know for sure, but it seems like the location of its worst impacts may shift depending on the heat waves in the ocean, plus the heat changes with the El Nino. And what happens is when there's more contrast between hot areas and cooler areas, then it can generate very, very high winds. So some of the storms that result from El Nino seem to be higher maximum wind speeds. And of course, there's a very nonlinear relationship between damage to, say, a structure from wind speed. It can be a certain wind, every house is fine, and go up like 5 miles an hour in the winds, and every house loses shingles or their roof. Storm surges are definitely becoming a bigger problem, especially with the background of rising sea level. You get a storm associated with the El Nino, that's a low pressure center, which sucks water up. And then, so the storm surges can be a lot higher and a lot worse. And the rate of precipitation can also be much, much higher. So torrential rains become even more torrential. And then that combines with the water on land and so on. So there's all of these different factors in play. There's some scientific papers that argue that maybe the El Nino cycle won't stay, it'll be sort of in the background and be persistent as opposed to less cyclical. Now, we know the ENSO cycle's been around a long time, as you said. I mean, it's definitely been around for the entire Holocene. We think that it goes back probably at least 500,000 years, even hundreds of thousands of years. But we have to look at records, various sort of proxies to figure out if that was the case or whether it was just a set of storm. We look for periodicity. We don't have great resolution, and we do in ice cores. So we can go back to the last ice age in Greenland, and in Antarctica we can go back 800, 900,000 years, but the El Nino didn't really have much change in Antarctica, right? And if we go to rocks and sediments from the ocean, they could tell us, but the resolution is not down to like a season generally. So it's really hard. It's a really good question, and maybe there'll be some proxies. We can get information on climate from caves, for example. When there's storms and stuff, there might be more water filling up a cave. Like there's all these different things that we're looking at, and it's like putting together a puzzle or trying to win a chess game. You have to bring all the pieces to coordinate them.
And it's one of the most important puzzles facing humanity. It's more than of just academic interest. So let me ask you a question. I think I know what you're going to say, but do you think that, assuming we do have, and even without maybe a super El Nino, temperatures hovering in the 1.7 or God forbid even higher next year for
Yes.
considerable period of time, along with the concomitant extremes in the tragedies that occur all over the world, many of which we've highlighted on this program. Do you think that that may prove to be an accelerant to climate action by world leaders and others?
And so now the question is, are we going to surge up to much higher levels? If it is a super El Nino, this is the question. So I'll go step on a limb and then I'll accuse you if the limb breaks and I fall off. But I don't think we're going to reach 2 degrees Celsius for an entire month, average temperature for an entire month in 2027, if there's a super El Nino. But I think we're going to be probably at least 1.8, 1.85, maybe even pushing 1.9. And then depending on how long this thing lasts, I mean, we could be there for a year or two. And then as it fades, we won't drop down to where we are today. That's the thing. I mean, the El Ninos, they normally come and go and the temperature goes up and then comes back down. But it seems to me the recovery is not as good as it used to be. Like I say, really study the 1997 to 98 El Nino. That's the biggest one in 50 years. What did that do? Did that affect you? And because it's going to be a lot worse if something that size hits us again on top
Okay.
of the overall warming.
Well, let's wrap up with this question, and that is to the degree to which we do reach into the high ones, 1.7, 1.8, 1.9 for an extended period of time, along with the impacts that one would associate at that level. Do you think that that may finally induce the world leaders to act more dramatically and more comprehensively on the climate crisis?
I think that remains to be seen, but I wouldn't like to put all the world leaders into one basket. I'd like to at least separate world leaders from the West to China, because at the present, I put a lot more hope in action from China. They'll just go do it. So many engineers that are building stuff for everybody in the world. I mean, they could easily go and do things that would change the climate. And I don't think they'll go ask for permission or buy-in from the rest of the world. I put my hope in what those leaders recognize about climate and whether they just decide to go and do something or not. I'd put more hope in that than having collective agreement by Western leaders to actually get their act together and say we have to cool the planet, we have to suck CO2 out of the atmosphere, we have to deal with methane. I think
Okay.
somebody is going to actually do it, start doing it, and the world might wake up and say, well, why are CO2 levels not rising as much as they should or whatever? And then eventually figure out, well, somebody's actually trying to reduce them. So I don't know. I mean, that's just me, but it's only because my mind is filled with China from some books I've been reading recently. And I
Right.
can tend to go overboard on things like that, I
Right.
acknowledge. So it could just be, I could say something totally different next week.
I have a couple of good books on Africa. Maybe I'll ask you to read those, and maybe we
I
can then,
will. I
and
will.
then
I
we'll,
love to
we'll switch
read.
over to an African perspective. Well, I want to thank you, Paul. As always, you have covered the issues comprehensively and with your brand of creativity and facts. Let me thank our viewers for attending. And now we turn to, as we always do, the Climate three of the biggest stories of the past week on the climate crisis. And I'm reporting this, you may notice, from a different venue. I'm actually outside of the venue for the Society of Environmental Journalists annual conference in Chicago, Illinois. And excuse any background noise from the trucks and the hustle and bustle of the city. And I'm also only going to report on Climate 2 today because we have a major story that we'll be covering in a special program of our organization coming up very soon, but I want to give you a preview of that today. But the first story has to do with an iconic life form, the white shark. The great white sharks are overheating. The evolutionary edge that fueled great white shark dominance for millions of years soon become its greatest downfall. The ocean's most iconic predators maintain warmer body temperatures than the surrounding seawater, and they're paying, unfortunately, an increasingly steep price for it. As the oceans warm due to climate change, they now face the risk of potentially fatal overheating, according to a new report in the journal Science. Several large tuna species and sharks, known as mesothermic species, for the way their bodies run hot, require more fuel to maintain their temperature and thus are confronting what might be considered a double jeopardy of warming oceans and declining food, mainly from overfishing. As temperatures climb, these species, like so many others, will be forced to relocate to cooler waters. So here's a quote: "If you're a shark, you just can't pop down to the supermarket and buy more food," said Nick Payne, the lead author and professor at Trinity College Dublin. We're seeing animals move with climate change in every biome, and this is just another example, and a particularly tragic one. So that's our first. And the big story is, I think most of you who watch are familiar with the AMOC, the Atlantic Meridional Overturning Circulation, that basically is kind of distributes heat and cool air throughout the entire planet, but particularly in the North Atlantic. It's a major part of the global climate system, and it cools and sinks to form a deep return current. A collapse would shift the tropical rain belt on which millions of people rely to grow their food, plunge Western Europe into cold winters, and add, believe it or not, as much as 100 centimeters, which is over 3 feet, to already rising sea levels. And a new study has come out, and the famous scientist Stefan Ramsdorf was quoted as saying, "I argued when we first thought the chance of an AMOC shutdown was maybe 5%, that even then we were saying the risk is too high, given the massive impacts. Well, with this latest study, it looks like it's more than a 50% chance of the AMOC collapsing in this very century. The most dramatic and drastic climate changes we see in the last 100,000 years, 100,000 years of Earth history, have been when the AMOC switched to a different state. And yet, and this is me speaking, not the article, the world does nothing. No emergency meetings. Have any of you heard about the United States Security Council holding an emergency meeting? How about the U.S. Congress or the Canadian Parliament or the Parliament of any country in the world except, I believe, Iceland? Basically, we're sleepwalking through this the same way we're sleepwalking through the climate crisis. So it's not great news. In fact, it could be catastrophic news. There's still time to act on it, but only if we, in fact, act. And with that, I want to thank you, as always, for watching our program, and we look forward to seeing you next week. Thanks so much. Goodbye.